Alright children, good morning once again. So we will start today from where we had left off. If you remember in the previous lecture we had studied the theory related to the calculation of the resultant moment. Now moment of force we have already studied. Moment of force is basically the turning effect that a force creates. Now forces may be many in number, 2, 3, 4 and so on and so forth. So whenever there is more than one force involved, then there will be more than one turning effects of those forces, and we may have to calculate the resultant moment as we have discussed in the last video that we had. So today I have brought with me a few unsolved questions from the book, so we'll solve them over here and I hope you all pay attention to it. So we'll start first with a couple of questions over here. Let's start with the first one. Question 1 says, a steering wheel of diameter 0.5 meter is rotated anti-clockwise. Okay, it is rotated anti-clockwise. So let us just underline this direction because this is important. Anti-clockwise by applying two forces. Okay, so there are two forces involved, each of magnitude 5 Newton. Okay, so draw a diagram to show the application of these forces. So this becomes the first part of the question, and once we have drawn the diagram, then calculate the resultant moment because of the two forces. So I hope you have understood the question, and as a part of the solution, now we'll begin. I have already drawn, if you can see, this is roughly what a steering wheel looks like. So how is it to be rotated? First, it is to be rotated anti-clockwise. Okay, so the direction of rotation has to be anti-clockwise. Okay, so anti-clockwise, we obviously already know anti-clockwise is this direction. Okay, so now where are the forces that are acting? How many forces are acting? There are two forces that are acting. Okay, so how are you going to hold the steering wheel? Generally it is held from this point and this point. Okay, so if you observe carefully, the two of your hands would be on the steering wheel like this. Now if you are to rotate the steering wheel anti-clockwise, then this hand should exert a force upwards and this hand should exert a force downwards. Only then it will rotate in an anti-clockwise fashion. So we have the first force F1. The magnitude of this force, as we already know, is 5 Newton, and this is the second force that they have talked about, and the magnitude is 5 Newton in this case also. Now, where is the pivoted point? The pivot. Whenever we talk about the moment of force or the turning effect or the rotation, we always talk about rotation about a particular point, and that point is the fixed point called the pivot. So if you see over here, this is the pivot that we are talking about. So now a steering wheel of diameter 0.5 meters. So diameter everyone obviously knows. If we draw this line from here to here, so this if we call this as point A and if we call this as point B, then AB is the diameter of the wheel, and the diameter is 0.5 meters. So obviously this becomes 0.25 meters and this becomes 0.25 meters. Okay, because these are the two radii of the same circular steering wheel, so these become the distances, respective distances. Now, so if you have analyzed the solution till now, you will find that the diagram to show the application of these forces is ready now. Okay, so this is the diagram. Half of the question has been solved. Now coming to the calculation of the resultant moment, as you see over here. So first of all, let us calculate the moment because of force F1 about Which point? It is always about that fixed point which is known as the pivot. So this is the pivot P. Now you have the moment of force F1 we are talking about first. So obviously the formula, if you remember, the formula was F into D. So in the first case we have F1 into D. This is your D that we are talking about. Okay. So when we put the values, the force value is 5 and the distance is 0.25. Okay, so when you calculate this, this comes out to be 5 5s are 25, carry 2, 5 2s are 10 and 2 12 and 2 places of decimal. So this becomes 1.25 Newton meter. If you remember the units we had discussed yesterday, force is in Newton, the distance is in meter, both are in SI units, so the moment of force will have a unit Newton meter. Now moment of force is always a vector quantity, so it will have a direction. The direction is already given in the question, anti-clockwise. Okay, so you will write anti-clockwise. Okay, similarly the moment of force F2 about the same pivot P will be given by the formula F2 multiplied by D, and you can very easily see over here the value of F2 is also the same and the D value is also same. So you have 0.25, so you have 1.25 Newton meter anti-clockwise once again. So now before we calculate the resultant moment, let us check whether these two moments are in the same direction. Are they assisting each other or are they opposing each other? So they are assisting. You see, this is also trying to turn it anti-clockwise and this is also trying to turn it anti-clockwise. Therefore, you can say that the resultant moment will be 1.25 plus 1.25, which will give you 2.50 Newton meter anti-clockwise. Okay, so this is what the resultant moment in this particular scenario is. Okay, now let us move to the second question that we have. A wheel of diameter 2 meters is shown below with its axle at O. So over here you see this is width. Okay, so a wheel of diameter 2 meters. Okay, so the diameter is 2 meters. So the diameter, if I draw the diameter from extending like this, you will have 1 meter over here and you will have 1 meter over here, because this point O, as you can see, the axle is at O, so this point O becomes the center of this wheel. A force of 2 Newton. Now in this particular case we only have one force, the magnitude is 2 newtons, is applied as shown. So you can see in the diagram over here, this is the point of application of the force. And how is it going to turn the wheel? It is going to turn the wheel like this, which is the clockwise direction. This direction is the clockwise direction. Okay, but the reason why this question has been picked up is because if you see the last line, calculate the moment of this force about. Now there are 2 points to this question, 2 parts to this question. You have to calculate the moment of the same force, but in the first case about a point O, which is at the center, and in the second part the moment of the same force about another point A, which is right below over here. So in this question the force is the same, but the pivot or the fixed point or the point about which we are calculating the moment, those 2 points have been taken differently. So let us first start with the first part of the question, which is the moment of force F about O. Okay, So again the formula still remains the same, force multiplied by the perpendicular distance. So the force value, as you can see, it is 2 newtons multiplied by distance. Now this distance actually depends upon which point you are taking the moment about. So here you are taking it about O. So from the line of application of force to the pivot, which is O, the distance is 1 meter. So you write 1, so that becomes 2 Newton meter clockwise. Okay. Similarly, if we go to the second part of the question, we will have moment of the same force F about the second point, which is A. The formula again it remains the same, F into D. The only thing that is different will be the F force. You can see it is still the same, but this time the distance D, since we are taking the pivot as A, so from the point of application of force to the new pivot A, the distance is 1 plus 1, which is 2 meters. So this becomes 4 Newton meters. The direction obviously is still clockwise. Okay. So this question has actually given us the idea, the clarity about the calculation of moment of force when the pivot points have been taken differently. So as obviously the two factors that decide the moment of force are F and D. As long as F and D keep changing, the overall moment will keep changing. So this was the second question. Okay, so here we begin with the next question in the same based on the same concept. Now this is a diagram. You can have a look at the diagram while I read the question. You see these A, B and C. These are the three forces. Okay, so the magnitude of these three forces, if you write force FA, the magnitude is 4 newtons. For all these forces, the magnitude of the force is 4 newtons. Okay, and the directions have been shown in the diagram. Now there is a fixed point O. So this point O, as you can see in between, this is a fixed point O about which there are three forces that are acting. Okay, and these are the respective distances that they have given in the diagram from the pivot to the point of application or the line of application of force. Now what's the question? The question is, what is the resultant torque? Okay, so let me write the question. Find the resultant torque. Now this time deliberately I have used the word torque because if you remember in the previous lectures, while I was dictating, while I was explaining the turning effect of force, there were three names: turning effect of force, torque, or the moment of force. So you should be familiar with all the names. Resultant torque. Torque means the turning effect. Okay, so now let us first decide how many turning effects will be there. There are three forces, so there will be three turning effects. Starting with this force, which is force A. How is it going to do the rotation? It is going to provide a turning effect in this direction. Look at the second force. It is going to provide a turning effect in this direction. So we can already see that forces A and forces B, they are actually producing, both of them are producing a clockwise moment, clockwise direction of the moment. So these two forces are producing the turning effect in the same direction, which is the clockwise direction. Whereas if you have a look at the C force has a direction that way, so it is going to provide you with an anti-clockwise direction of torque or the moment. So whenever the word resultant comes, we have to find the algebraic sum. Okay, algebraic sum means with the proper sign. So let me first write down, this is the clockwise direction, this is the clockwise direction, and this is the anti-clockwise direction. Okay, so let us find the individual moments first. So we will have moment of force A. I will use the short form like this. Moment of force A will be force value multiplied by the perpendicular distance. So obviously when I am using this force, the perpendicular distance will be this much. So this will be 0.9. So the answer will be 3.6 Newton meter clockwise. Okay, so clockwise. You can either follow the sign convention. If you remember in the previous lecture I had shown you, you can either write 3.6 Newton meter clockwise, or you can write minus 3.6 Newton meter. So that minus sign would indicate the clockwise direction. So now coming to the force, moment of force B. So for this again, the value of the force is the same for all three, but the perpendicular distance this time will become 0.8. So 4 8s are 32. 3.2 Newton meter. Again the direction is clockwise. Similarly, we have the moment of force C, which will be 4 multiplied by this distance, which is 0.6. So 4.6. 4 into 0.6 will give you 2.4 Newton meter, but the direction this time will be anti-clockwise. Now, having calculated these three individual moments, the resultant moment about O will be now this is anybody's guess. These two, since they are in the same direction, they will get added up. So you will have 3.6 plus 3.2 and 2.4. Since this is in the opposite direction, so it will get subtracted. So you have 6.8 minus 2.4, which is going to give you a value of 4.4 Newton meters. Now, very important, the direction. The overall resultant moment will have a direction, clockwise direction, because the two clockwise moments, the value after adding them up has come out to be more than the anti-clockwise moment. So the resultant turning direction will be clockwise for this system. So this is what our answer will be. Okay. Okay, so now the next topic in the same chapter will be couple. Now since we are quite familiar with the force, the multiple forces, their turning effects, the resultant moments, now let us study what a couple is. So couple essentially, let us just first understand what a couple is. A pair of forces producing a turning effect. So this turning effect that we were discussing till now, it's not a singular force that creates that turning effect. There is always a response, a reaction to one of the forces. So that makes it two forces, a pair of forces. Now the important point, the technical points that you have to remember about a couple is, there will always be two forces. Okay, they will always be acting in opposite direction from each other, and their magnitudes will be same, and they will be acting along different lines of action. Okay, so now keeping these 4 points in mind, let me draw a diagram for better understanding. Suppose this is the pivot point P, there is a force F1 of 5 newtons acting over here, and there is another force F2 of 5 newtons acting over here. Okay, so in this particular diagram, now in this particular setup, my question would be, does this setup form a couple or not? So we'll go by these 4 checkpoints. Okay, are there two forces present, F1 and F2? Yes, they are present. So the first criteria is fulfilled. Coming to the next criteria, acting in opposite directions. Are they acting in opposite directions? Very much so. This is acting upward, this is acting downward. So the second point also is true. Same magnitude. Are the magnitudes of the two forces same? Yes, they are pretty much same. So there is a tick here also. Now these 3 points are quite simple to understand. Now what does this point mean? Acting along different lines of action. So the line of action, if I draw of this particular force, this is the line of action of first force, and this is the line of action of the second force. So these lines of actions are very different. They are not same. I'll give you a scenario where they are same. You see, again, this is a pivot, and suppose this is a force F1 of magnitude 5 Newton, and this is a force F2 of magnitude, same magnitude, that is 5 Newton. Now again, my question would be, does this system also form a couple? Let us check. Okay, so as far as this was concerned, all these 4 points were satisfied. So this was a couple. This was an example of a couple. Now this is the second scenario which will help you understand all these 4 points more clearly. So let us check once again. For this setup, two forces. Are there two forces? Yes, there are two forces. So we will put a tick. Are they acting in opposite directions? One is acting down, one is acting up. So they are acting in different directions. Do they have same magnitude? Obviously yes. So the first three points are okay. Now the fourth point, acting along different lines of action. The lines of action of both these forces, if you see, it is the same. It is the same. So the logical question would be, why is a couple used? It is used to create a turning effect. Now in this particular scenario, when the lines of actions of both the forces are same, do you think it will create a turning effect? No, because the upper force will try to put it down like this, the lower force will try to do the opposite turning effect. So in effect, actually there will be no rotational effect, no motion. This is an equilibrium case. Okay, so this does not constitute a couple. Okay, so this is not a couple. Okay, I hope you have understood the concept of the couple. Now just as we studied force and then moment of force, similarly after studying couple we will study moment of couple. Alright, so continuing now, we have the moment of couple. Obviously the moment word is related to couple because couple creates a turning effect. So that turning effect of the couple, what is the formula going to be? Either force. Okay, so it is going to be either of the two forces. Why either of the two forces? Because both forces are same, the magnitudes are same. So if you look at this new diagram with the details that I have drawn over here, there are two forces acting, they are in opposite directions, their lines of actions are different, their magnitudes are same, so they constitute a couple. Now, moment of this couple about point P. So the moment of a couple, if you want to calculate, if you want to go by this formula, you see either force. So even if you want to take this, anyone you can take, the value is same, 5. Multiplied by perpendicular distance. This is the symbol for perpendicular that I have drawn. Perpendicular distance between the two forces. Okay, so this time the pivot will not come into play. This time the distance between the two forces. So 1 meter plus 1 meter, that makes it 2 meters. So that becomes 10 Newton meters. Once again, the direction is extremely important. Now you just see whether these two individual forces, what sort of moment are they creating, which direction is the moment being created in. So this will create a turning effect like this force will create a turning effect like this. In effect, if you see, this is actually helping each other. Okay, so these two forces are helping each other in providing a clockwise direction of moment. So you will write clockwise. Okay, 10 Newton meters clockwise. This is the moment of this couple about the point O. Okay, I hope you have understood the units as well as the directions. Okay, so the next topic that we will have to start now is equilibrium, which is a state of equilibrium. Basically, equilibrium is of two types. Equilibrium means stability. Okay, the stability can be achieved in motion also, it can be achieved while the body is at rest also. So equilibriums are of two kinds. We will have one as the static equilibrium, the other one will be dynamic equilibrium. Okay, but before we go into the details of this, let us understand a basic general understanding of what the term equilibrium means. Now, just before this, a few minutes back, we had studied couple. Okay, couple had two forces, the magnitudes were same and they were acting in the different directions. Now you have a look at this particular scenario. There are two forces acting, but both of them are acting downwards. Okay, they are both acting downwards. Okay, the pivoted point is over here. Now you see, this will create a turning effect in this direction, this will create a turning effect in this direction. Now if you see, because of force F1, the direction of turn is anti-clockwise. Okay, so this is going to be anti-clockwise, whereas this is going to be clockwise direction. So they are basically actually opposing each other. So once the two moments, if they match each other, if they equal, if they neutralize each other in different directions, then we achieve a state of equilibrium about that particular fixed point P or the pivot P. So let us check numerically. If we want to calculate the moment of force F1 about the pivot P, you will have, the formula will be F multiplied by this distance. So you will have the force value as 2 multiplied by the distance as 5, so that will give you 10 Newton meter anti-clockwise is the value of the moment of force F1 about P. Similarly, when you calculate the moment of force F2 about the same pivot P, you will have this F value, which is 10, multiplied by this distance, which is 1. So this also gives you 10 Newton meters clockwise. Okay, so if you see the basic difference between this and these two values, both are moments of the forces about the same pivot P, but then this direction is anti-clockwise, this is clockwise, so they are going to get neutralized. Therefore we will have a situation of equilibrium. We will have a situation of equilibrium. From this particular concept comes the principle of moments. Please write this down. You have principle of moment. What does this state? That in equilibrium, sum of all clockwise moments will be equal to sum of anti-clockwise moments. Sum of anti-clockwise moments. Okay, please remember this principle of moment. This will be very beneficial in the calculation, in the solving of the numericals. What does the principle of moment state? It states that whenever there is equilibrium, wherever there is stability, all the clockwise moments added together and all the anti-clockwise moments added together, they will come out to be the same, of the same magnitude, and therefore they will get neutralized because their directions are different. As was the case here, 10 Newton meters, 10 Newton meters, the value is same, but the directions were different. Therefore, this was a situation of equilibrium. So whenever they say there is equilibrium in a particular question, that obviously means that all clockwise moments and all anti-clockwise moments, the overall values will come out to be the same, and therefore they will get neutralized. Now the only last remaining part is, why did I say sum of all clockwise moments and sum of all anti-clockwise moments? Because over here in this particular example, there is only one clockwise moment, there is only one anti-clockwise moment. So the answer to that would be, you can always have a number of forces acting on the left side, number of forces acting on the right hand side. So they each will create their own moment, individual moments. They will be added up if they are all in a clockwise direction. they will be added up together. All anti-clockwise forces, they will be added together, so that if they come out to be the same, the situation will be equilibrium. Okay. Okay, so now over here, if you see, I have taken up a question to explain that equilibrium situation more in detail. You see, let us just understand the question first. This is a meter rule. If you can see, this is a meter rule. This is the pivot point O in the center. 50 centimeter this way, 50 centimeter that way. So this is a uniform meter rule that we had discussed, if you remember. At the 40 centimeter mark on the left side, you have a 40 GF force acting in the downward direction. 40 GF is the force. GF, if you remember, in one of the previous lectures I had discussed, GF is one of the units of force, the gravitational units of force. The question is, where will you place an 80 GF weight to balance the above setup? Now, before balancing, let us see the situation just now. 80 GF weight we have not put just now. So this situation obviously tells us that since there is only one force acting on the left hand side, therefore this is not going to be in the equilibrium position. This is going to get tilted in the which direction? On the left hand side direction, downwards, obviously. So if you want to balance, the important word is balance over here. If you see, the important word is balance. Balance means equilibrium, a state of stability. Okay, so if you want to create stability, obviously you have to place this 80 GF weight on the right side. But where exactly is our question? Okay, where will you place the 80 GF? So since we don't know, let us assume that we are going to keep the 80 GF force on the right side at a distance of x centimeters from the pivot. Okay, remember, after placing of this 80 GF, there are two moments that are getting created now. One because of this force, and the direction is anti-clockwise. So this is anti-clockwise, and because of this GF, 80 GF, it will be clockwise. So you will write clockwise direction over here. Okay. So again, if you remember, according to principle of moments. According to principle of moments, what does it say? In equilibrium, what happens? What happens? Sum of all clockwise moments should be equal to sum of all anti-clockwise moments. Okay, so let us look for clockwise moments. There is only one clockwise moment, this one. What will be the formula? The formula will be force, which is 80, multiplied by its perpendicular distance from the pivot, which is x, equal to sum of all anti-clockwise moments. There are no multiple anti-clockwise moments. There is only one anti-clockwise moment because of this force, which is 40. So the formula will be F into D, perpendicular distance. Please remember, it is not going to be this distance. It is always going to be the distance of the force, perpendicular distance of the force from the pivot. The pivot is over here. So we are going to take this 40 centimeter distance. How do we know this is 40? Because this mark over here where the force is acting is 40. So you have the distance also as 40. Therefore, x becomes 40 into 40 upon 80. 40 2s are 80 and 2 20s are. So this becomes 20 centimeters. Okay, so your answer would be, now let us read the question once more. Where will you place the 80 kg of weight? So we will place, my answer will be, we will place the 80 GF weight at 20 centimeter on the right on the right of the pivot, on the right side of the pivot.